Good everyone, welcome to the second video in our series of sedimentary depositional environment. So today we're going to cover alluvial fan. Now, what is an alluvial fan? Now, can you see this sketch? Now, the first thing you have to know is that alluvial fan is a kind of depositional environment that is occur in a mountainous region. Okay, these are mountains, and this is how it looks like. You see this? So it comes out from it is an alluvial fan. Now, the alluvial fan, what are the characteristics and what really forms it? The main characteristic of the main factors that are responsible for the formation of it, they include the low rainfall, very low rainfall, low humidity. So those are things that cause the formation of alluvial fan. So for some mountainous region, due to when rain falls very slow, low humidity, okay, the kind that is why the kind of sediment that you find in alluvial fans are not fine. They are more of coarse or medium grained. Okay, they are more of coarse. They are very large because they have not really been transported very far. So because the means of transportation, okay, the factor responsible means of transportation includes gravity and water. Let me briefly discuss that. So if you have in a mountainous region, okay, so some sediment, weathering happens, right? So weathering is the breaking down of a rock, right? Larger rock into smaller rock. So when weathering happens, so some of those particles and rock or boulders or cobbles or pebbles, they begin to fall down under gravity. They begin to fall what? Down under what? Gravity. Good. So that's why gravity is one of the factor in that. So wedging occurs, gravity is involved. Now, another factor that can involve in transportation of the sediment involves low rainfall, which is water, right? So low humidity. So when there's low rainfall, it will also not allow the sediment to be transported so far. That is why the description for the kind of fishes that we have here, based on their texture, they are not actually fine. They are more of coarse grained. They're more of coarse grained, large grained kind of sediment. Okay, good. Now, since you know the sediment comes from what? Mountainous region. They fall under gravity. We have gravity flow, stream flow. That I just explained. Now, alluvial fan can be divided into three parts. We have the inner fan, the mid fan, and the outer fan. The inner fan, the mid fan, and the outer fan. Okay. So now, when we talk about the alluvial fan, I want you to journey with me. So if I take you to where the alluvial fan is, if we are at this place, inner fan, what will you see? I tell you that um the kind of sediment, hmm, how fine or how coarse is dependent on the journey from its source. Okay, journey from the source. So if this is the source now, where the sediment came from, so if it's journeyed so very far, the grains will be more smooth, like more rounded. Let's use the geological term, rounded, maybe spherical, okay, and even sorted, well sorted, very well sorted. But if it's closer to the source, like what we have in the alluvial fan setting, it's closer to the source. You have things like what? Polysorted, polysorted grains, okay, angular, more angular, not rounded. You have angular size. Good. So, which means that yes, the textural maturity and the mineralogical maturity of the alluvial fan is generally immature. It's generally mature, but some specific parts are more mature than the other. What do I mean? Since the alluvial fan is formed near the source, it has not journeyed so far, right? The sediment has not journeyed so far. So generally, texturally it is what? Immature. And mineralogically it's texturally immature, right? And mineralogically it's also what? Immature. Now when we say something is mineralogically immature, what are we saying? Now, a sediment that a kind of rock or sediment setting that have been mineralogically mature will consist of pure quartz. What I say? Quartz. You see quartz inside it. But we are still seeing things like feldspar, mud, like feldspar. This is like feldspar, mud, because this mud or clay or these kind of things, clay, silt, because these kind of minerals are actually they are subjected to weathering. Subjected to what? Weathering. Why for quartz? Quartz is very, very resistive to weathering. So that is why for a sediment that have transported very, very far from its source, the main mineral that you see there will be what? Quartz. But if you are still seeing feldspar inside that sediment there, what you're going to say that what? It still have tendency of what? Immature. Okay? So that sums it up on what? Mineralogically definition of our texture. Now we talk about texturally immature. For texturally immature, we're going to talk about the sorting, we're going to talk about the ferricity, that is the grain shape. The grain shape. Is it well rounded? Is it spherical? So we can even talk about sphericity or roundness for the alluvial fan in general. So the alluvial fan in general is textually immature and mineralogically what? Immature. So if you are asked to what is the texture? Okay, what is the texture? What's the grade of the texture of an alluvial fan setting? Generally, you say it was immature, both texturally and what? Mineralogically. Now, but there are parts of the alluvial fan that are more mature than the other. You know, I told you that the closer you are to the source, the more immature that you are. So if I ask you now that for the middle fan and the outer fan, which is more mature than the other? The outer fan is more mature than the middle fan. The middle fan is more mature than the what? Inner fan. And the outer fan is mature than both the middle fan and the inner fan. But generally, they are textually what? Immature. Okay? Good. So next, we are going to now speak on something. We're going to speak on something which is on the textural attributes. Textural, textural attributes. Textural attributes of the outer fan. Textural attribute of the what? Of the outer, sorry, inner fan, I mean. Of the inner fan. Textural attribute of the inner fan. Now when we talk about the inner fan, okay? When we talk about the inner fan, you know, one of the attributes you're trying to describe it. One of the attributes of it is the depositional sequence. The what? The depositional sequence. The depositional sequence of the inner fan is not clear. Is what? Is not clear. Not clear finding upward. What I say? Not clear finding what? Upward. Not clear finding upward. Okay? Not clear finding upward. Second, it consists of it consists of massive bedded massive bedded deposits of conglomerates of what? Conglomerates and what? Breccia. You know, as I said, they will have quartz grain, and you know, quartz means big, fine means small. That's the layman word. But in geology, we use quartz and we use fine very well. They are texturally mature. We know that already. They are texturally what? Immature. They are texturally immature. Texturally immature. Good. Now, this is the textural attribute of the what? Of the inner fan. The depositional sequence is not clear finding upward. Now, I want to just talk about the depositional sequence, which is which will take us into logging. What did I say? Logging. Now, for a finding upward model and crossing upward model, what does that mean? If we say depositional sequence model, like a fishy model, okay, how will we know something that is finding upward, crossing upward? Finding upward means it is getting smaller as we are going upward, which means you're having smaller grains as we are going upward, which means you have bigger grains and you have smaller grains. You know, fine means small. So as finding upward means getting what? Smaller as we are moving upward. Now, coercing upward depositional model, saying that what? We can have small, but we are having big. Can you see that? So this is what a coercing upward depositional model. But for the inner fan, because in that place, it will still not be very, very clear. Okay, it's not very, very clear. It's very, very close to very close to the source. So we can even talk about the depositional model because everything is very, very poorly sorted arrangement of all the sediments and everything. So that's why we say that what it is not clear finding upward depositional sequence. Okay, we understand the rest. Now, if we talk about the outer fan, for the mid fan, for the mid fan, one good characteristic of the mid fan is that yes, it is texturally mature. It is mature than the inner fan. It's more mature than the inner fan. But in this place now, we don't have we have a structure. Okay, we have structures. Sedimentary structures have begun to form here, but they are crudely formed. What did I say? Crudely formed sedimentary structures. Crudely formed sedimentary what? Structures. Okay? Crudely formed what? Sedimentary structures. So they are not well formed. It has begun to form in this area, but the kind of this area is crudely formed sedimentary structure. In this place, there's not even any sedimentary structure at all in the inner fan. So the mid fan, we have crudely formed sedimentary structures, and the sizes of the grains have started to introduce some kind of mid grains into it. Okay, some medium grains, but it's still more of coarse grains. So now for the outer fan is more mature than the what? The outer fan is more mature than the mid fan and also the inner fan. But for this one, the sedimentary structures have started to be well formed, have a well formed sedimentary structures, sedimentary structures. We have between coarse and also medium grains kind of um, soil texture, then coarse to medium grains, coarse to medium grains kind of sediment in it. So I've said earlier, this sums the textural attribute of the inner fan, the mid fan, and the outer fan. Now, we're going to talk about the logging, how to log our fishes, how to log fishes, how to log fishes. So in next video, we're going to talk how to log our fishes. So kindly stay tuned, share my videos to your friends, your geology friends in other schools, and in life. Okay, thank you very much. God bless you. Okay.